Okay, good morning. We're studying complex numbers today. So, what are complex numbers? Why do we need them? Where do they pop up? It's all because of negative numbers showing up under square root. Well, if a number under a square root, you can take a calculator and compute it, and calculator will give you either whole or decimal number or never-ending repeating number. But basically, you can compute them. 3 squared, 2 goes into 2 once, comes out 3. However, when I put a tiny little mark before 9, make it minus 9, when you try to take a calculator, take square root of minus 9, it will tell you error, right? So no such real number. In our real world, real times, you can't find such a number. So what do you think math people did in this case? Did they just quit and go home? No. Oh, if there is no such real number exists, why don't we make one up? They made up a number for it. Okay? Since all the symbols for numbers are taken, so they started using letters for it, and they use letter I. From now, whenever you see I in any question, it's not the letter of the alphabet anymore. It stands for a number in math, and that number is square root of minus 1. So they declared from now on, when I have a negative 1 under square root, I will call it I. It's just definition. You can't say wrong. You need to obey. Okay, they just declared it I. You can't reason. It's just like they declared 0, 1, 2, they are declaring root negative 1 to be I. Okay?
Just a bunch of cheaters.
Yeah.
Making up their own rules.
Right. They're making up their own rules. This is their game. Okay. Question is, alright, we do know what root minus 1 I is I. So it is I. How about minus 9? How am I going to come up with a symbol for it? Are we going to call it J, K, L, M? No. We will quickly run out of letters if we do that. So this is what they did. Why don't we... So it's actually, I'm starting the second part. Why don't we, anytime we see a minus sign inside, we take it out, remove it from the square root, and call it I, and the rest will be, look, once you remove the minus as I, the rest will be a real number. And you can compute it with regular old symbols you've been using since kindergarten, right? So what is root 9? It's 3. So you have I times 3. But we like numbers before letters all the time, so they called it 3i. So shortly, this is the rule they made. When you have root minus 1, we call it I. But if you have any more numbers, bigger numbers inside, you call it I times the square root of the positive of that number. And you simplify this number and try to compute this if possible. If it's not possible, you just leave it like that. Okay? So for this to stay in your mind, I know you may forget it, just think that this like that, with this example. Negative sign inside a radical. I mean, radicals are prisons, right? Jail. This is jail. This is an inmate. Negative is a disease or virus. You need to cure it before simplifying, multiplying, dividing those radicals, adding those radicals. You need to cure the disease. Okay? And whenever you see minus, you need to fix it. And how do we fix it? Just wipe it off and put I outside. That's it. Wipe it off, sanitize it or disinfect it, and get it out of jail, and your jail will be positive, nice, cured jail, positive, and you can compute it. Always fix the disease first. if you see a minus before you attempt to do anything. That's the rule. It's that simple. Alright, let's start computing some square roots, well-known square roots we've been dealing with before. What is square root of minus 169? 13, right? We just break 169 into numbers, possible two numbers, and I can't come up with other than 13 and 13. And I get 169 is 13 squared. So this thing is 13 squared, and it cancels with this, and I get 13 as a result. Correct? No. This is not 169. It's negative. And you can't do any of these until you cure your patient. This is a sick guy. It has a negative. We cannot compute negative square roots. So how do you cure that disease? Here is the disease. Here is the virus. Kill him. How? Before doing anything else here, we need to take that minus as out as I. So this is I positive square root 169 now. And then you repeat everything else you did before. That's 13 squared, and 13 squared is gonna pay off the guard. 2 goes into 2 once, so 113 will come out. 13 to the 1 will come out, and no 13 will stay inside, so they cancel away. But again, we don't like putting I13. Okay, the tradition is we bring the number in front, put the I afterwards. Okay, so you flip number and I call it 13I. Any questions? Is it clear? Alright, let's go to the next one. How about this? First, fix the disease. Do we have a disease here? Yes, minus. So I'm taking that minus out, I out, and now you have a perfect 27. Positive 27. Is that all? Are we done? No, you need to always simplify inside. It's a big number, 27. Possibly you may have some factors pulled out. What two numbers multiply to 27? 9 and 3. What else? 3 is locked. 9 can be split into double threes. So we have triple 3 situation here. And the guard only demands $2. How do you save 3 out? 3 goes into 2, no, 2 goes into 3 how many times? 1. Subtract. This is how many 3's left? 1, 3 left inside. So I will leave it here. 1, 3 left under the square root. How many is coming out? 1, 3 coming out. I brought 1 out, 1 in, and I. Okay? Now there are different ways you write this answer. First, one option is you put I between free guy and jail. 3I root 3. I've seen in some textbooks they put I to all the way to the end. This is also possible. You bring 3 root 3 to the numbers in front, keep the I on the end. Okay? I like this a little bit better, so I will use this. Okay? 3 root 3I.
Neck back, set both.
It should. Let's try the other one as well. I root 3. Let's try first. Yeah. Or you can put again I to the end. But this is wrong. Why is this wrong? This is in jail. You can't put I in jail. It's free. I is always free. Just put it outside. Okay. Alright. Going forward, this time you have two jails with disease. Do you see that? Do you see two jails with disease? One here, one there. And you have an operation between them. You have a multiplication. Oh, shall we go ahead and combine those diseased jails? What?
Fix the disease.
Yes, fix the disease first. Most people think they straightforward, okay, this is wrong. What I'm doing is wrong. Don't ever do it. I still want to do it, okay? Alright, but I see this all the time in the tests. So don't do this. People see, oh, these are free guys, so I must first multiply free guys. Minus 5 times 3 is minus 15. And then, oh, there are two jails. So we multiply j's by combining them. So they multiply minus 9 and minus 1. They combine two inmates into the same roof, same jail. And what happens? Minus 9 and minus 1 multiplies. It becomes positive 9, and they say, you see, disease is gone. They were sick. Now when they combine those two jails combined, they are healthy. It's positive. And square root of 9 is 3 squared. 2 cancel, and they say 15. This is just 2 and 3 when they cancel. The answer is minus 45. Everything looks according to the rules. No objection. But we are violating one important rule. You cannot combine two sick jails. They have diseases. You cannot combine them yet. Looks correct, right? Minus 9 times minus 1 makes positive 9. Positive 9 comes out as 3. 3 times minus 15 is minus 45. But when you enter this, you're going to get disappointed. It's going to say incorrect. Then how do we fix these diseases?
You combine them once you get the same like base radical. Further ahead. But I'm just asking you.
So where the
If you were to get two base like radicals that you fix the diseases and you get your same, would you combine them?
we can combine once we fix them. Yeah. So we need to first disinfect, sanitize those jails before we multiply. So take again those questions, but instead of minus 9, put positive 9. So where does the minus go? Minus go in front here. Minus, the disease is out, cured as I. Same thing for this. 3, positive 1 now. I fix the disease. Where did the disease go? In front, I. Then multiply next. Multiplication happens among free guys. Free first. Then jails will be multiplied. Okay? Again, these are all multiplication. You don't have to FOIL anything because there is no addition or subtraction sign. If there is an addition or subtraction, we distribute and FOIL it. But this is all, everything is dotted, multiplied, product. So minus 5, 3, I comes together. Minus 5 times 3 times I is how you multiply free guys. Now we combine the jails. 9 times 1. Okay? You see the jails? 9 and 1. Blue and black. Under the same roof. Here comes the important part. Everybody knows how to multiply 5 and 3, right? It's 15, minus 15. Question is, how do you multiply I times I? It's I squared, yeah. If you have double letter, it means square of it. Question is, Can I further compute I squared? Do I know what I squared is? Yes, we do. Look. This is important. We skipped it, but forgot to mention, but whenever you square I, it's part of the definition. They not only called root minus 1I, this is also definition. Square of I is always to be taken as minus 1. When you see a square of I, you should be happy because it's no longer an imaginary number. It's a turns to a real number. So kinda it's an antidote. It's a fix for I. I gets a square, it's cured. It turns from evil to good, okay? And it becomes minus 1. So having an I square is a good thing, and this is now a minus 1. And this part is 9, positive 9. Everything is smooth here because it's sanitized jail. And we can get square root 9 as, what is square root 9? It was 3. Because 9 is 3 squared. Square cancel with square root. And look what we are getting in the end. Minus 15 times minus 1 is positive 15. Positive 15 times 3 is positive 45. What is the difference now in our results? It's no longer minus 45, it's positive. When you first fix the jails and do multiplications, the result is positive 55. You get it? Any questions? Alright, this is a long chapter section. Alright, we will be doing this for a while. Now, what is the operation now? Let me mark things here. There are still 2 jails, but the operation between jails is, what is this sign? Subtraction. It's not multiplication anymore, it's subtraction. And remember subtraction of jails back in 10 point what, I don't know, but we subtract 2 jails if and only if there is a requirement. You can't just subtract any 2 jails. They meet the same index and same inmate inside. Inside radicants, prisoners must match, and also the type of the prison must be the same. If they are square root, both should be square root. Okay? Now they are both square roots here, but first thing I notice is inmates not matching, so I cannot subtract them yet. More importantly, I cannot subtract because they are sick. You need to first fix those radicals, negatives. Fix the negatives, okay? So how do I fix this negative? By calling them out and bringing an I in front. Agree? Now, jails are clean. We need to simplify them. To perform this subtraction, I need to get same inmates in each radical. This is 3, this is 27. We need to work on 27 and fix it. But we did it a moment ago, so I'm going to cheat. How did you guys simplify root 27? What did it turn into? 3 square root 3. Just look at this solution again if you want. But this thing is 3 root 3. Okay? 6I root 3 minus. Okay, there are 2 free guys now in front of the jail. 7, 3, and I. I is also free, but they're not quite like 7 and 3. They don't combine. But 7 and 3 will combine into what? 7 times 3 is 21. So it's technically 21I root 3 you guys have here. Alright, fact check. To be able to subtract 2 jails, radicals, they must match in index. Both must be square root. Are they both square root? And inmates must match. Then how do you subtract 2 radicals like that? This is radical 1, radical 2. by putting a big parenthesis, copying this here, and doing what in this parenthesis? Yeah, subtract the guys you have here from each other. So it is 6i take away 21i. What is 6i minus 21i? Just think like this. 6 apples take away 21 apples. How many apples do you have left? Negative 15. Right? Negative 15. You don't have any apples. You're taking a loan on apples. It's negative. So it's negative 15i root 3. You don't need a parenthesis. Once you've taken care of this operation, you can remove the parentheses and even put I to the end or to the middle. I don't care. Alright. This is it. This is the result.
How come you want to subtract the i's though?
How come you're not subtracting i's?
Yeah, because you're doing 6i minus 21i. How come you want it?
Just think like this as x's. 6x minus 21x. Do you subtract 20 x's here? I is just a variable like x, okay? Just imagine like that. So we don't subtract x's and cancel them away. Or just in real life, you have 21 feet long stick and 6 feet long stick. When you subtract these 21 and 6, you put still feet symbol here, right? But you don't subtract this and cancel feet. Just think like that. So it's just, this thing is kind of, think of it as a unit. 21 meters Celsius Fahrenheit. X is just a symbol, okay? So you keep it all the way, whatever the numbers changes into, you keep one sample. I is that same thing. I is just standing for a variable, for a something. It's root negative 1. So it's kind of variable. Alright, going on forward to the next question. Alright, you're on this one. I want you to, because there is no new trick in this question. It's old stuff. Do it for a minute and let me know the result if you have any. Chris objects and says 30i, negative 30i, positive 30i. Any different answers? Anything different? No? Okay, let's do the right one. First, we need to fix these minuses. So the first one turns into I 36. The second one turns into I 25. I'm calling minuses out. Okay? And then I see big fat numbers inside. I will turn them into factors. Especially if I can get a square, I'll be just happy to get a square. I will factor all the way. Can you make 36 into a square? What number square is 36? Everybody knows that. Yeah, 6 square. And 25 is 5 square. So these squares will cancel. And we will have I6, I5. Okay? Alright, next we multiply numbers with numbers, variables with variables. These are all multiplied. Multiply, multiply, multiply. 5 times 6 is 30. I times I is I squared. So is this the final answer? Looks like you're both wrong. This is the right answer, right? Now when you have I squared, we know the value of I squared. It is minus 1. 30 times minus 1 is minus 30. Okay? Okay? You were right. Starting next. Division. Can you divide these two jails? You know the deal. They are not ready for division until you cure them. Sanitize them. First, I move minus out and fix the first radical and turn it into I root 44. Do we need to fix anything on the bottom? No, it's already positive. Next, I break these numbers into powers and see who I can save from this jail, each jail. 44 breaks as, give me two numbers multiplying to 44.
22 and 2.
2 and 22. This is locked. 22 breaks into 2 and 11. So you have double 2 there and a single 11. On the bottom you have double 2. Everybody knows square root 4 is 2, but I still do it in baby steps. 2 and 2 cancels. And same thing here. 2 and 2 cancels. So 1, 2 comes out, but 11 is still stuck. So it's I 2 11 over 2. I cancel 2's and get I and 11. Okay? Next. Almost the same question. No, not technically the same. Two. Any different answers? Just 2? Only one answer? Alright, let's see how this one works. Again, we need to first fix the minuses. I call them out. Yeah, I can't. Okay, take the minuses out first. We get I root 52, I root 13. Alright, here is something great happened. You have one same letter or number or whatever you call on the top and bottom multiplying some stuff. If they match, you can cancel them. You can cancel i's. Okay? Next, we have 52. You just need to break 52 into parts. What two numbers multiply to 52? 2 and 26. Yes, and then another 2 and 13, it's 2 squared 13. And there is nothing you can do on the bottom. 13 is a prime number, it won't break. But this 2 squared can be taken out as 2, because 2 and 2 cancels. And if two radicals on the top and bottom matching and multiplying other things, you can cancel them. So the answer is just 2. Okay? Alright, here is an alternative way of doing this at this stage. If you have two sanitized jails dividing each other, you can, we first cancel these, they go away, of course. If two jails are dividing each other, you can combine them into one jail and divide the inmates inside. And you see 13 goes into 52 4 times. Get root 4. Root 4 is 2. This is alternative way. But you only combine two jails into one if you foresee a division is happening in the second line. Like if this was 17, I wouldn't combine them. Don't combine them if it's 17, because 17 doesn't go into 52. You do it if they are canceling. Alright, going forward, we have powers of I coming up. You not only get square of I when you're in your computations, you may get more powers. So we already know I is equal to I. There is nothing you can do about I. If it is I, it stays I forever in the result. But in your result, if you get I squared, you already knew this one as well, it turns into -1. But any other high power, cube, fourth, fifth, sixth power, must be computed. So in your answer, when you do your computations, you end up with I to the 6th. Connect Math is not going to accept that answer. You need to change I to the 6th and compute it. So this is the pattern that it's computed. I cubed is square of I and one more I, right? 3 i's. We already know I squared as -1. I is I. And it turns into -I when you simplify. Got it? I to the 4 is product of I squared and I squared. Each is -1 and it totals to 1, +1. I to the 4th is 1. I to the 5th is I because it's I to the 4th times another I, and I to the 4th is computed as 1, so it turns into I. And I to the 6th is -1 again because it's I to the 4th, I squared, etc., etc. Okay, somebody sat down and did this up to 12. Thank you. I appreciate this work. Somebody sat down and computed up to 12, but this work was not waste of time. It gives us an idea, this table. It actually presents us a pattern. There is a pattern. These powers are growing and keep getting the same number. Look, I to the 1st became I. Look what happened for the 5th power. Once you do it 4 times and go to the 5th one, it gets the same value. You do it another 4 times, 5, 6, 7, 8. When you do it the 9th times, look what you got. It's again I. So you keep getting same value at increments of 4. You increase the power 4, still hitting the same value. So can you tell me what I to the 13 will be? Can you? I. That's the pattern. And 17 will be I. 21 will be I. 25 will be I, etc., etc. Did you get the pattern? So how do you do the other ones though? Square 6 and 10. 4 increase, 4 more. 4 more. So when you add 4 more to this power, guess what I to the 14 will be? -1. I to the 18 will be minus 1, right? Okay, I will just do the last one again. 4 more, you have still 1. 4 more, still 1. 4 more, I to the 16 is 1. I to the 28 is 1. Do you see the pattern? Do you get it? Question is, how do you get I to the 69? This is still a lot of work. Are you gonna keep adding 4, 4, 4, 4, 4? Because what if this was not 69, 699, 8, 7, 5, 6? Are you gonna do this all weekend? Keep adding 4, 4, 4 all day, every day?
Odd numbers.
Top one's always going to be odd.
No, it's not that simple. There is more algorithm to that. Yeah, there's oddness, evenness, but no, there is another approach. So here is what you're gonna do. Take this 69, and everything is related to 4, right? 4 more, it keeps repeating. Divide 69 by 4. Divide 69 by 4 by long division. How many times 4 goes into 6? 1. How many times 4 goes into 29? 5? No, 6, right? 7. I'm not good at math. 4 times 7 is 28. And I'm marking this part. I don't care about this. I'm marking this. Guess why? This is gonna tell me which one I'm going to pick. You have one of the 4 choices. I to the 69 is gonna be one of these. But this tells me which row I'm going to check out. Guess which row I'm going to pick. 1 is pointing first row. So the result is I. Do you understand? So because these are keep repeating the same thing after every multiple of 4. So that's why I'm dividing 69 by 4. And there are 17 multiples of 4. So it keeps repeating to same value after 17 rounds of 4. And there is still one I left. One I left, and that's here. If this would be 2, I would pick the second one. If this is 3, I would pick the third one. If it's 0, what do you do if it's 0? No. You don't see it 0 here, but if it is 0, you pick the 4th row. Look, there are actually 3. This is 1. Remainder 1 is this one. Remainder 1 is this. Remainder 2 is this. Remainder 3 is this. But can you have a remainder 4 in a division of 4? Can you have a remainder 4? No. So this can't be remainder 4. Then what is this? This is remainder 0. If you have a remainder 0, you pick the 4th row. If this was 68, for example, I would get 0 remainder, and I would pick this one, 1. Because it's an even multiple of 4. Every multiple of 4, look, it turns into 1. 16, 20, 24, 28, 32, 36, 40, 40, 44, 48, 52, 56, 60, 70, 64, 68, 68. Yeah, 68 is getting 1. You see? I can even count. Alright, next. You do I-101. First right answer gets credit. Come on. 101. You can even do this on top of your head. Divide by 4, check the remainder, and pick the value. What? I. Do you agree? Look, 101. Divide by 4. 4 goes into 101. 4 doesn't go to 1. 4 goes into 10 twice. 4 goes into 21, 5. And the remainder is what's important to me. 1. 1 means first row, it's I. Correct. 25. Oh, this is easy. It's I again. Yeah. Computer assigned these numbers randomly. It kept getting I. Do we have a different one? No. I just want to make a challenging one then. How about I to the 4,237?
Negative I.
Wow, that was quick. Negative I is one answer. I don't know the right answer. I actually do. Is this the right answer? Let's do the division. Or do you want to revise this answer? You want moment? What is the remainder you have left when you divide this by 4? Four goes into 4 once. 4 goes into this 5.
It's just I again.
4 goes into this. Yeah, it's I again. I kept getting the same thing. Alright. Okay. This doesn't count. About 226. Yeah, this time is different, right? Yeah, finally I got 2. I got 2 and 2. Second row is -1. Finally. Okay. I think you got the idea. Now, the title of this section is complex numbers, but I didn't speak anything about complex numbers yet. All we talked about was I. Complex numbers is a number made out of i's. How? It has 2 parts. A real number, so these are the stuff we've been dealing whole semester. These are the numbers you're used to. So this is all number system you have. You take a real number and add b many i's to it. B is whatever number you pick. Add it to old number. You get 2-part number like this, a plus bi, a number plus a number times I. That's what we call a complex number. Okay? And whenever you create a number and I is present, we call that number imaginary number, because I cannot be real. It's not a regular number. It's something imaginary. So we call it this thing imaginary number. Okay? So if b is 0 though, if this is 0, if you take this number 0, then what you get is just a, and a is already a real number. It's a number you are familiar to. All semester we've dealt with those numbers, right? However, if b is not 0 again, if it's visible like 14i and -18, and we call it imaginary number, I already mentioned that. This is called also the standard form. This is called standard form of complex numbers. So when question asks standard form, you need to put it in this form. I will show you how. And whenever you flip the sign between those two numbers, a and bi, you create conjugates. You're familiar with this term, right? Conjugate means opposite signs in the middle. We've done this with radicals, JLs. Remember? You created conjugates and multiplied top and bottom so that you can rationalize the denominator. It shows up again. Complex conjugates are just opposite sign in the middle. Complex imaginary numbers. A minus bi, a plus bi. And when you multiply them, they turn into beautiful things. So this is important again. Just like in radicals, complex conjugates help us simplify things. turn them into beautiful numbers. All right, our first 3 questions is about recognizing what real and imaginary parts of a complex number. Again, this is called a complex number, but a complex number consists of 2 parts, real part and imaginary part. So which part of this is called real? Which part? What? Anyone? Negative 18. So this is real part. Okay. How about imaginary part? Anyone? 14. Okay, when I ask, there's a misconception. When I ask imaginary part, people name this whole thing 14i as imaginary part, but no. We mean the number in front of I as imaginary part, so don't include I to it. It's only 14. So when you put I, it's gonna say incorrect. You only take the number, real number in front of I and call it imaginary. Alright. Wow, this is shocking. I don't see any eyes on this question. So, what is the real and imaginary parts? Can I still identify them? What is real part?
16.
The whole thing is real already, so it is 16. But what do we put in the imaginary part then?
0.
0, yes. Thank you. Yeah, we skipped 12 and 13. So real part is 16, but although you don't see it, there is still this next to it. It's 0i. You have 0 many i's next to it. It's hiding in there, invisible, so you have a 0 in front. That's the imaginary part. Okay, going back to 12, what is the real and imaginary part of this? This is pure I, no numbers before. So it's actually technically there is a 0 plus minus 21i here. So this is real part. This is imaginary part. Okay? So for a pure imaginary number 21i, no prior number before minus, real part is assumed 0. Imaginary part,
You type negative 21 on
yes,
full thing.
yes, negative 21 is whole thing, yeah, with the sign. You put the imaginary part. Okay? Alright, we are almost halfway. This was introduction. We're gonna have more challenging operations, multiplication, division, and simplification part coming up next Monday. We have no class on Friday, right?